So today what we have is a customer repair. It's a DNT M40 and not sure we're going to do his display. Came to me really sorry. It's the same gentleman with the York 863, which he'd done a lot of the work to. Cleaning, looks better, removed the covers, lots of work done, redone the power lead, replaced the DX local switch and the DIMM plug. He said, I only have plastic DIMM plugs and we have those metal ones, don't we? The biggest argument with these is they get trodden on and easily misshaped. And I like the gold pins on ours. So he couldn't get the 10.24 crystal to change. Because of that, the channels are all over the place. I'm starting this at 8:45. Not that early, but I'm off doing Mrs. Swatsit's shopping this morning as part of my church work, and I know that someone is dropping in their Midland 76 900 base station, and I did say to them, whenever you drop that in, we will do that as next job. They're only about 12 miles away. So, okay. Be like that then. Let's see what it smells of. It smells of somebody's damp cellar. So we'll connect it up to the test equipment. Plug in the mic. Switch on picture in picture. And see how many watts it's... Oh, we're not plugged in. I'm just trying to wreck his PA. That's what it's about. I was doing that walkie-talkie yesterday, the little Harvard WT1, so I'd unplugged the main connection to the test set to use crocodile clips. That's what that was about. So we're in 3 watt scale, radio's doing 150 milliwatts, it's on low power, radio's now doing just over 3 watts. Wallow. Deviations as you'd expect, around 2.2, and whether or not it receives anything we will find out. We plug in the instrument speakers. 79125. And that's what we're receiving. Nothing! So that's not on at all. Now, we've done these before, and I'm not looking at any of the last notes. We'll go through it again and come to the same conclusions. But basically we have to set the 10.24 to as close as we possibly can. Sometimes it won't quite go. And then we set the transmit, because it has a multi-crystal mixer, doesn't use the normal type of synthesizer chip. It uses a general purpose Motorola, whatever. I printed off the circuit for what it's worth. Wrong paper in printer. MC145106 by the looks of that. This is just from the instruction book, which these were handily printed within. So the first thing we need to do is to hook up to the 10.24. In fact, the first thing we need to do is take the bottom off the radio and just see whether we can get anywhere. Now, even when these were new, they were suffering from dry joints. Double-sided board, linked through just with tin-plated pins. So, a bit of a snag, like the grandstands can be, like the realistic handheld we were doing the other day can be. I've seen a lot worse, very long way than this. Bear in mind it's 38 years old. That looks like some kind of modification, but I really don't care. Anyone noticing the F and the G filter, it is supposed to be the F and the G filter. They're not supposed to be equal. So, 10.24 is the crystal here. So, let's just see where that's put on to. It's pin 3. It's between pin 3 and 4 of the synthesizer chip. So, we'll go to our frequency counter and switch that in. See if we can get anything on pin 3. I'll just put that up on the screen on the inset. That looks like pin 3. I can't remember whether to pick it up off pin 3 or pin 4. Just try the other input. Different inputs, different sensitivity. Might use our other oscilloscope. Just pause this. I'm not sure what recorded and what didn't on this video, so apologies if it was about 3 minutes. Did the transmitter, did the receive, got about 0.85 microvolts out of it, which isn't very good. And we're going to check the S meter. So 20 dBs, sorry, start again. 100 microvolts, we want this to read S9. We've got some dry joints as well. It's upper one. If it wasn't misbehaving. Try again. S9. Let's see whether we can find that dry joint. Right, I think we're just about there now with this. I've been struggling with the transmitter. You know, we couldn't get more than 3.5 watts out of it. When I looked more closely, there was a wrong transistor fitted. So 2SC what? It's come out 1307. I checked back with the circuit, should be 2078. Found one on a scrap set, so we'll just charge him a token quid for that. Came out of a Midland 100M illegal AM set, so that's and oh, we're on the wrong screen. And now we're getting a full 4 watts, and it peaked at 5 as I tuned it up, so that's satisfactory. We'll just melt the wax back on these. I'll put the spectrum analyzer on. We'll just look for any naughtiness of signal. Had quite a lot of dry joint snags with this. That's our fundamental. Oh, we're on the wrong screen again. So that's our fundamental frequency. Let's put in 54 or 55 or something like that. Centre frequency is 55 now. There's actually nothing there, so that's fine. Oh, let's see if there's anything stupid like up aircraft band. No, there's nothing. There's our fundamental. That's it. That's pretty good. So just to check, we've got 4 watts there. We've got 0.4 watts there, which it doesn't like. It does not like that. Likes that better. Meter now reads what? That's fine. We set S9. We've got 2779.125. Do we want? Tell you what, we'll turn picture in picture off for now. So I don't know how much of this got recorded and how much didn't. That needs just twiddling down. It's S9's a bit generous, and it is the RX meter is the one furthest away from me. So that's that. The attenuator works. So we'll drop that to a meaningful signal, then switch that on, and it works. So will the squelch work? Set squelch. Switch off signal generator, or switch it to standby. Switch the squelch to full. You get what you're given, there's no adjustment for this. Comes in at 3 microvolts, and that's a bit weak, but that's how it is. So once again, we'll set the squelch now to threshold, bring the signal generator back, parked at 0.3 of a microvolt, switch it on, straight in at 0.3, goes off at 0.2, comes back at 0.31, goes off at 0.2, so it's nice and sensitive. So what is the sensitivity finally? I don't think it's that good. There are the super tuned versions of these around, which were modified by Cleartone Electronics and actually work very well. But the standard ones like this don't work very well, and they're a bit of a bleed over box. But nevertheless, here we go. Switch that back on. Switch picture in picture back on. We're on. Select that. It's there. See where we are. So we've ended up with, well, we've ended up with 1 microvolt for 12 decibels. So I don't think we're going to. We'll have one more twiddle. I'll regret this, I tell you. No, not going to get any better. Still 1 microvolt. Okay. So that was riddled with dry joints. I've spent an awful lot of time doing dry joints. It'll probably be back to dry joints by the time it's been through the post. But there you go. We're going to do a scratchy corner test when I've put it back together. So I'll put it back together and we'll stick it on the aerial. Oh, and then I realised that it didn't have the speaker connector, did it? So we'll just do the speaker. Guess where that goes. In fact, it might even show on this diagram. It does. That's handy. Well, that's obvious. As far as I'm concerned, the other one will go to the outer. So unplug the instrument speaker. Hey! Turn the signal generator off. The first thing we've got is no longer transmitting, so open it up again and see what's wrong. Okay, that got rectified. It was the relay and they can play up. I just sprayed the contacts and it's now back to working. 1 Anna Roger. Well, Anna Roger. And we'll just put the little handheld on. Testing 1 2. Testing 1 2 1 2. Testing 1 2. Right, we'll do an on the air test with that. and we'll see how 1 microvolt sensitivity works in real life. Thank you for watching the rather tired and rather fragile DNT M40 from 1981.